All right, so we're going to be in chapter 3, which is just data description. So it's going to be basically analyzing data a little bit more than just looking at data. The first topic is just measure of tendency, which is your mean, median, mode, mid-range, and range. Those are just to name a few. This will actually be our build-up to what we like to call, I don't think we get to it this chapter, but next chapter we'll have what we call a box plot. And box plots basically takes these tendencies and put it on a, I say box, it's a box and whisker plot, but that's basically what that information helps you make these guys. So we'll learn how to figure it out, and then we'll learn how to graph it in the next chapter. All right, so measure of tendency are also called averages. Notice the purpose of each, how to use to describe the data. One thing too, you probably ought to remember this, but mean is what? Good, the actual average. And then median is the middle number. Mode is most often. Mid-range is literally the middle of your, it's actually your range there. But what statisticians can do is they'll take one of those values and say that that is your average to skew their data. So like if the average is a little low, but their mid-range or their median was a little higher, they might end up using the median instead of the actual mean to skew their results. Right? Go ahead. Median. I think that's someone that can talk to the dead. Not to my knowledge, I don't know. Range. That's mid-range. Yeah. So range is largest minus biggest. Mid-range is largest plus biggest divided by 2. Yeah. Yeah. It'll be more, there'll be more math in the next one. Yeah, I like it. That was the hardest test ever made. I've never made a vocabulary test. I feel like that was I think a couple hours. Yeah. But just right there working with Miss Smith, just working away. All right, anyways. So some parameters and statistics. Recall the definitions of a population and sample. So recall a population is all subjects involved. Sample is only a part of the subjects involved, or what they like to say, some. Measures found by using all data values is in a population are called parameters. Parameters. Measures found by using data values from a sampled are called statistics. So if we're looking at the entire population and analyzing that, that will be our parameters because that's what actually is occurring. If we're just looking at a sample of the population, now we're looking at statistics to assume what the entire population would be, right? But we want our sample to be large enough where it'll be relatively the same. We want statistics and parameters to be the same, but statistics is always going to be skewed one direction. There's so many days I got to remember I'm an adult. And I can't just like go to her room and be like, come on in. I heard him first period. Yeah, I can hear him through the walls. All right, here we go. So general rounding rules. In statistics, round only after the final answer. Do not round prior to. You always want to do it at the very end. All right. Intermediate rounding increases the difference between the answers and the exact value of the statistics. Also, what will happen is, we'll get more involved in this, is when we have margin of error will come into play there, and you want to keep that margin of error small. If you have to increase your margin of error because you've round it so much, your statistics can be thrown out, saying that there was too much rounding to conclude the results that they concluded, right? And you don't want that to happen as a statistician. All right, so the mean here again is the arithmetic average. It's where we actually add them all up and divide by ever how many there are. So that's a arithmetic average, which again is found by adding the values of the data and dividing by the total number of values. Remember this in 6th grade? I know this because me and my 6th grade teacher are literally preparing this to teach their 6th grade students. So it's kind of cool that we're doing the same thing. All right, so round the calculated value of the mean to one more decimal place than occurs in the raw data. Then we'll add the 0 as a placeholder to tell the reader that that's what we round it to. All right. So basically, like if you got the answer of 47.54, you'll just say 47.50, and the reader will know, all right, you are accurate to the 10th place. If you forget the 0, then the reader assumes that you are accurate all the way to the 100th place. And that's not necessarily true because that's where we'll be rounding at. All right, just to keep that in the back of your mind. All right, the population mean. You're about to see a lot of notation. And what's about to happen here is instead of me asking what the population mean is or what the sample mean is, I'm just going to write notation like symbols, and you have to know what that symbol means. All right. So for the population mean, it will be denoted with what they call a mu. And it looks like this. So you start down here and then you make like a U like that. That is a mu. So if you see that symbol, you are looking for the population mean, meaning you're looking for the actual mean. All right. Questions on how to draw that? Yes, sir. So you start underneath it, underneath the line, and kind of go up and then make a U after that. All right, this is calculated by using all the values in the population, and the population mean, remember, is the parameter. It's what actually occurs. Oh, this, by the way, this is more of a typed mu symbol, so you can kind of see what I'm trying to draw there. So if you see that symbol, that is a mu, which means population mean. And this little equation here, if you don't remember these symbols from pre-cal, did we even get to sigma in pre-cal? I don't think so. Maybe in algebra 2. This little sigma here, this right here, this just simply means sum of. It is also a sigma sign if you needed to know what it was. Make a G. G. Sigma. All right. So that's sum of, and the X there just means all of the variables or whatever the situation in, and the capital N just represents how many there are. Like if there was 100, I'm adding up 100 numbers and then dividing that result by 100. Right? I don't want to do that by hand, so a lot of these things we'll also kind of do in like Excel, or we'll use the calculators or whatever the case might be. Right? All right, so when X represents a data value of the population and N represents the total number of values in the population. So there you go right there. And the X, again, is all the data values. N just represents how many there were in the subject. All right, we good there? All right, the sample mean is denoted by an X bar, which is basically just an X with a line above it. All right. So if you see a mu, you're talking about population mean, which is the actual mean. If you see an X with a line above it, you're talking about the sample mean. So you're taking whatever the sample of the population and finding that average. Yeah, okay, so yeah, if you have the entire Midwest and Southwest all in one group, but then you're going to do a cluster sample out of that, yes. Well, that's perfect. It would still be a sample. If it's already separated and you're just taking one section of it, you're still taking a sample of the entire population. If you're looking for the actual population mean, which is the mu, you'd have to combine both clusters. Yeah, if they did the work of separating, that just makes your life a lot easier because then you can just add that result up and be done. All right. Again, the sample mean is the statistic. And again, this is the thing I was trying to draw. I still go with this X here, but you can use a regular X if you would like. This is a better X than that one. Goodness. So that's what I was trying to draw, but it looks like a third grader drew it. And again, it just takes all of the values of X that represent all the values in the sample. Go ahead. Yes, sir. And then this right here is then adding them all up. Little n just represents how many in that sample of the population you're pulling from. All right. So any questions on how to find population mean or sample mean? Any questions on notation? Because that gets people. That got me when I was in y'all's shoes the first time. I was like, oh, what does this one mean? All right. So in statistics, Greek letters denote parameters. So anytime you see Greek letters, you're dealing with the entire population. And Roman letters, like what you see here with the X, that Roman letter, anyone know what that means? 10. Yeah. They denote statistics. Any questions on that? So Greeks have the entire population. Romans take part of the Greeks, right? Ain't they part of the same country? I don't remember. No. Didn't one try to conquer the other? Which one was it? Who won? Neither? Nope. All right. Assume the data are obtained from samples unless otherwise specified. Oh. So in our first example here, it says salaries of college, university, and coaches. We saw this one already. It says the data are salaries of 30 colleges and universities, and we're going to find the sample mean. Did it do it for you? It didn't? Oh, good. All right. So you can do this in one of two ways. You can just do it, or you can plug it into programs. I don't know what would be faster or easier because you're going to have to plug it in anyways. So here's my recommendation. Grab a calculator if you have not. Gotta have both. Mine's split. 6. So do y'all want to just add them all up and divide by 30, or do you want to see like different programs? Yeah. Not so much on those, but like on an Excel sheet or the Inspire. But the issue is you're still typing in all the data and then got to do more. So in my opinion, I feel like when it's just asking for like one question, I feel like just doing the work is easier. But if it was to ask for like all of it, it might be easier to use the program, like especially like median and type of thing, like when you're looking for that center. All right, so we're looking for the sample average, Ezekiel. We're looking for the sample average of our 30 coaches. There's a calculator already on your desk. No, because we have Nick Saban's in there making $684,000, so it's not going to be 190. And we're looking at the 30 college universities. That's a good guess. But let's look it up because we don't want to guess. Did you give up, Rivers? Yes, you're adding up all 30 numbers. We can. Sure, we can do it together. Let's see what we got. So I'm gonna go, man, what would be quicker? Think this way. I'm gonna go 164, 225, 225, 140, 188, 210, 238, 146, 201, 544, 550, 188, 415, 261, 164, 478, 684, 330, 307, 435, 857, 183, 381, 275, 578. Oh, there's another row. Sorry. Oh, 450 plus 385 plus 297 plus 390. You might want to do it each, like plus enter, plus enter, plus enter. So you get 10,404. You can if you want, if you don't trust me. Malachi, did I miss any of them? I heard you saying he's like on his third row, and I was like, all right. And then what do we do with that total? 346.8. Sound about right? All right. That's what we're going to go with. Well, 380 was pretty accurate. That was pretty. 346.8. Okay. We're not going to do any rounding here because it doesn't ask us to, so we'll just keep it as is. Had we had a lot of decimals, we might round to the tenths or something, but we're good with this. Any questions on how to calculate by hand? However many you got. That's it. So statistics can be a little time consuming or tedious math, but it's not like you're solving for like a big equation or something like that. Yeah. All right. Any questions on that? All righty. All right, so in the previous chapter, we constructed a frequency chart with 8 classes for the sample. We're going to use the frequency chart to calculate the mean for grouped data. This process is most frequently used when the raw data is not available. So there is your equation right there. To find the population mean, because that's what the, not population, sorry, sample mean, because that's what the Roman numerals is. Is that the last number? Hold on. Right, the sigma is part of the equation, but then it equals, yeah. But that's a good catch because sigma is a Greek letter. All right, so where F is the frequency, so you're going to be multiplying it, and XM is the midpoint of the class. We did all of this work in our previous chapter, so they're not going to make us do it again. All we're going to do here is just figure out all the calculations, so that on the next step, we can then take the sum of all of them and divide by how many we have, all right? These are just different things they might want you to do just to analyze some different data. So what I want from y'all, since I did the work last time, all you gotta do is take the frequency and multiply it by XM, which they're calling the midpoint. So what's 11 times 184.5? No, we're not dividing. We're just going to multiply it all down, add them up, and then we'll divide once we have their totals. Just multiplying straight up in this first column. He just picked up the calculator. All right, what's the next one? Sorry to call you up. What? Not yet. Yeah, we're going to add them up once we have all the results. Yes. This will be the total. And then the next part of that question is to find the actual mean. We'll need to divide it by however many we have. But there's a lot of pre-work we got to do. See, I like Excel, but the issue with using like these programs is that you have to plug in all this work before you can use the program. It's really nice if they like start you with the program and then you can just do all the math. Are we stuck on the second one? Oh, what's the second one? What's the next one? What's the next one? Next one? What's this last one? Or this next one, sorry. Oh, that one's hard. And then these should be just 74.5, and this was 814.5. Go ahead. Which one? Uh-huh. 76. So our calculations were 544.5 times 4. I have to agree it's 78. I got you. Now you want to add them up. So we did all the pre-work to find out this guy right here. So 110,395. Do I got a second on that? All right, perfect. So that right there is now the E part. So this is the sigma when you found the total. Now to answer that last part, when you're actually looking for this guy, we need to divide by n. Well, how many are there? How many? 1, 2, 3, 4, 5, 6, 7. Yeah. So divide that number by 8. What? Yo, yes. Sorry, this my bad. I do apologize. The total that we got. Divide that by 8. So you got 103. I mean 10,395. You divide that by 8. Oh, sorry. So that's okay. N represents how many there are in the sample. We calculate it by dividing it by the class limit. We have to go by in the sample 30. Well, then why didn't you say something? Just because I'm up here does not make me the professional. Next semester, I'll be the professional. I got to figure out how to do this. So what'd you end up getting this time? All right, that looks better. All right, so we got 346.5. And we calculated earlier 346.8. So when you compare the sample means calculated from the raw sample data and from the group data in the frequency chart, you can still see it's still relatively close. It's only off by 0.3. Right. So sometimes maybe instead of adding all 30 of them, we could just simply have done this math. It's a little bit quicker, a little bit less to do. Oh, well, we don't know. We're just seeing that it's roundabout. I mean, plus or minus 0.3. That's not a huge margin of error. It'd be different if we're like plus or minus 3 whole numbers. That could be a big skew depending on what we're dealing with. But seeing that you're dealing with hundreds of thousands in salaries, really and true, if you're 3 numbers off, you're only like 3,000 off. So that's not too bad. 0.3 here, it's like $300 that we're off. So that's not a huge number. Maybe for some, like when we're like, they can't afford Whataburger right now or something like that. Like $300 will be like real nice in our pockets, right? But this is just basically mean this is a different way to calculate the same type of answer to give you less work rather than having to add all 30 of those numbers like we did earlier. So it's something to keep in the back of your mind. I do got there's a little question here at the end. Oh, let me erase this. I don't know if y'all have this. The mean is always or is not always an actual data value. I think it can go both ways. It really just depends. So it's not on this one. It's actually it can be both. Is always and is not always. Oh, true. I like it. So if it's always, it always has to be it. I like yours. So it's not always. Right. So it could technically be the same answer as your parameter, but it might not be. But hopefully we're relatively close and not too skewed one direction or anything like that. All right. All right. So properties of means. The mean is found by using all values of the data set. So depending if you're dealing with the population or the sample, remember you're going to use all the values. The mean of a data set, oof, this is a lot, and they give you a little space, is used to compute other statistics. Other statistics. Such as the standard deviation, which we haven't told you about yet. Writing. Like trying to read the writing. All right, so again, used to compute other statistics such as the standard deviation. We'll talk about the standard deviation, I think more like tomorrow. Deviation. Deviation. The mean of the data set is not necessarily one of the data values. And what they're basically saying is we got what an answer of 346.8 and 346.5. Was that any of the 30 numbers that we had? No, it wasn't, right? Well, we didn't have any decimals. We might have something close to it, but it wasn't the actual value. All right, so not necessarily will be one. Sometimes it does, depending if you're dealing with a lot of repetitive numbers. To find the mean of a frequency distribution, there must not be an open-ended class. I don't know. To find the mean of a frequency distribution, there must not be an open-ended class. I assume, I guess, a class that you haven't calculated anything for. Like even that one that we had, we at least calculated 0 for the frequency distribution. Like it has to have a result. You can't have gaps from the beginning to the end, is what my assumption would be. So no like blanks. You can have 0, just no blanks. The mean is affected by extremely high or low values. So we have Nick Saban's salary in there that was like 648,000. And those are called outliers. I can't spell. Liars. Outliers. So again, so anything that's like high or low can pull our mean average up or down. And that's what the outlier is. And I'll teach you either in this unit or the next chapter how to take out those outliers or what's being most effective depending on where it falls in the quartile. And I'll tell you what that word means later down the road. Any questions on mean though? I'm getting ahead of myself. All right, cool, cool. Let's talk about the median. All right. So as you already told me, the median is the middle, or also known as the center. So it can be considered center or middle of an ordered list of data. Very specific there. It must be in order, either from least to greatest or greatest to least. It does not matter what direction, but it needs to be in order so that you can find the exact middle of the list of the data. All right. The symbol for median is capital MD or MED. Right. I've seen it more as MED than I have capital M and D, but you might see both in this textbook. To find the median, again, you're going to arrange the data from smallest to largest, but it doesn't have to be. It can go largest to smallest. We're then going to determine the number of values in the set. So like, for instance, we had 30. And then what you want to do is find if n is odd, the middle data value is the median. But in our case with 30, what's halfway between 30 and 30? 15, right? So you'd have to go 15 from the left, 15 from the right. And what you're going to do, since the n was even, you would add those two numbers up and divide that by 2 to find the middle number between the two values. Now you get real nice if those two values happen to be the same. So if they're both like 205, 205, then obviously what's our median? 205, right? But if you get like 200 and 205, then your median would be 202.5, right? Any questions on that? All right. So let's look at our next example. So this one is the salad dressing one that we did on the last unit as well. It gave us 36 different salad dressings per 1 ounce and told us how many calories were in each of these salad dressings without telling us what the actual salary was. And they did something nice for you. It is already from lowest to highest. So my question to you is, how many what's our n in this case? How many samples do we have? 36 of them. So I don't have to, a lot of people, and I've seen it, and I did it when I was a kid, is I would literally go here, 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 just to find out what the middle number is. But if you cut 36 in half, what number are you at? Huh? No, and I used to do it as a student too. But if it's 18, just go 18 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if I'm 18 this way, where do you think I'm going to fall over here? 18. But you can check yourself. That's 3, 14, 15, 16, 17, 18 right there. Right? So, and this is what I was talking about earlier. When these two numbers are the same, what number's between them? 130. So your solution of the median is what? 130. Any questions on how to find the median? Now this was nice because they put it in order, but what makes this kind of tedious is to put it in order. The median and mean? It is. It is. We don't have a midpoint. That's not a definition for statistics. That's totally something different. Midpoint, again, yes, in algebra was the middle of a line segment, right? You'd calculate the distance and find the middle of it. But we don't have midpoint in statistics because we're not looking at lines really, unless you're looking at a line graph. Mm-hmm. Yes. Make sure it's at least to greatest or greatest to least, and then find the middle number. And that's it. Well, we haven't gotten there yet, but this will be 130 if you haven't written it down. All right, let's look at the next example. And this is number of tornadoes per year. I don't think we've done one like this, but it's not that big. A number of tornadoes per year, according to the National Oceanic and Atmospheric Administration, the National Centers for Environmental Information, reports the number of tornadoes per year. All we're going to do is find the median. So how do I do that? Don't count it in order because it's not currently in order, is it? No, it's not. Oh, yeah. You need to put it in order. Yes. So I'm going to go 881. Nope, I lied. There's one smaller than that one. 878. Then 881. 891. 1156. I could technically just stop here because after this point, they're only going to, I could see that out of 7 numbers, the 4th number is my middle. So yeah, so I could just stop there. If you wanted to finish it off, you would see that it would still get to that point. I didn't do what I was explaining. What was your method? Okay, cool. As long as you got to the same conclusion, I don't care what your method is. All right. Any questions on how to find the median? In statistics, we always hope it's real small numbers when we have to do math. And it's not something like there's 100. All right, so here's all the review for the properties of median. So again, the median is used to find the halfway point. I forgot the F, halfway point. Or Charlie's favorite word, midpoint. It's still the middle of the data, right? So it's halfway point or midpoint of a data set. The median is used when one needs to determine if a data value falls in the upper half or the not upper half, also known as lower of the distribution. The median is not affected very much by outliers. So that's a big question there that could show up on your test. Mean is affected by outliers. It can pull it up or down, but median is not affected by outliers. All right, because we're just looking at the middle of the data. It is. The median can be used with open-ended distributions. So this, you could have some blanks in there and you still get to the same conclusion. All right, we'll continue this Wednesday.